Hey, Jody here with WeldingTipsAndTricks.com. Thanksgiving holiday is right around the corner, so I want to take a minute and wish everyone a happy Thanksgiving. And whether or not you celebrate Thanksgiving, enjoy your families, take care of your families. Let's get to welding. Okay, so this is where we left off last week. This is part 2 of building this heavy-duty set of bookends. 1/2 inch thick steel plate, 1.25 inch pipe with some socket weld 90-degree elbows for that industrial overkill look. And they are to replace this flimsy set of bookends here that are shaped like hands that I ordered off Amazon that my wife wouldn't let me put in the house, and she was all like, these things are the most heinous thing I've ever seen. And I was like, what do you mean heinous? And she was like, you have no taste. And I was like, shut up. And then she was like, oh, let's not fight, I love you. Okay, so a little review of part 1. Cutting the 1/2 inch plate with a plasma cutter, gapping the socket weld 90-degree elbow 1/16 of an inch, getting it straight, getting 2 tacks 180 degrees apart, and then I welded them out using this little technique called walking the cup. That's a good way to weld socket welds if you can do it. If you can't, you just have to find a place to prop. Put some marks on there with this wide base square, and then I'm using the little 90-degree magnets here to hold the 1/2 inch plate while I get a tack or two on it, and they make it pretty doggone easy to do. And I'm always working by myself. I don't have anybody to hold something while I tack it, so sometimes little things like this can really help. Oftentimes I would just lip it just a little bit, get it close, get a tack on there, tap it around until I get it 90 degrees, but the magnets do save some time. And like with any magnet, you don't want to weld really close to a magnet. It'll make that arc wander all over the place. But I put them about a 1/2 inch away and got a real quick tack on there, and it worked okay. Getting a few extra tacks, and then the bookend is going to go together like this. Putting the piece that I cut, the socket weld 90-degree piece that I cut on there like that, and I'll use the magnets again to square that bottom piece up and get a tack or two on it. Still testing out the little Pyrex cup here. I'll give you some more information on that after I have some more hours on it. I'm going to get 2 or 3 tacks on each joint here. Make sure it doesn't move around as I weld it. I'm going to use this cup for just a little while today, and then I'll change to a standard cup. I'll explain why in just a minute. I'm using the Lincoln Square Wave TIG 175, a nice little basic TIG welder, and I've got it set for this weld up pretty much maxed out, 170 to 175 amps. I'm welding 1/2 inch plate to the pipe, which is about 150 to 160 thousandths wall thickness, so it takes a good bit of heat to get a decent puddle going on something that thick. Now, one thing about the Pyrex cup that I never really understood why they were that good, but you can see, you can kind of get an eye shot of that filler wire dipping into the puddle through the Pyrex cup. So sometimes there are times when that could be a benefit. Cup so far so good, getting good shielding, but now it's time to go ahead and swap over to a number 8 gas lens cup, regular ceramic alumina style cup. Because like I said, I'm around 170 to 175 amps, and the cup was rated at about 170 amps by the guy that makes them. I'm using 3/32 ER70S2 filler wire, 3/32 2% lanthanated electrode. Most any electrode would work equally well on DC like this, seriated, thoriated, laser, E3. You wouldn't be able to tell much of a difference on this job with any of those. AC is where you really tell the difference on the electrode manufacturer and composition. Just dipping a little rod in there, trying to dip it about once a second and move the same amount each time, trying to anyway. Not always doing it. There are 4 of these welds, so I'm giving you quite a few different angles, quite a few different looks. Welding away, welding towards, right-handed, left-handed, all that stuff. Figure I might as well show as much as I can because I filmed quite a few of these little shots. This looks a lot the same as the previous shot. But again, trying to about once a second dip the rod in there. And now you can see I've hooked the rod around a little bit because I got a bad angle. It was hard to reach the rod in there, so I put a little curl on it, a little bend, so that I could weld about 1 inch before the rod straightened out, and then things got okay again. I got a more favorable angle that way. The trick is, when you're going around something round like this, is to kind of plan ahead and move your wrist, do what you got to do to not get crazy on the torch angle, because gradually you can get to have way too much angle if you're not careful. All done with the TIG welding. I'm going to put some welds on the 1/2 inch plate now, and so for that I'm just going to use stick. I'm going to start off using this little Miller Thunderbolt AC/DC machine, but you can see I've got quite a little groove to fill there. So I'm going to start off with 70/24 rods, 1/8 70/24, and they are these little Blue Demon rods that I ordered off Amazon, and they are not impressive at all. And I'll show you that in just a minute. I've got a fan set up there to kind of blow the smoke away. Sometimes having a fan, if you position it right, is better than a respirator, because you get that smoke completely away from you. Doesn't ever reach the helmet. But you can see this is a very heavy, slaggy rod. There's a lot of flux on a 70/24, and that's normal, but this particular rod is just not acting like it should. It's just not running very well at all. I had to crank it up a lot hotter than I thought I should to get that slag pushed away. 200 amps on AC is what I'm using on this 1/8 rod, and that's just more than it should take. And it's just not welding all that great. Slag should be coming off there a lot easier than that. Granted, it's kind of hot, but this is at 165 amps, and watch right here, all that flux and slag just swirling around there. I had to crank it up to 200 to get enough arc force to keep it all pushed back to the back of the puddle. And their amperage range on the box said 120 to 170, I think. So I was up around, you can hear the machine groaning. So maybe some issues going on there too. I'll talk about that in a minute. I'm running the second pass here with the same 70/24 1/8 rod at around 200 amps alternating current. And it's just something's just not quite right. Just not flowing like a 70/24 should. And it doesn't look quite right either. The ripples are kind of pointy. There's some little deep ripples that are kind of holding on to some slag. Normally a 70/24 will look like glass if it's run right. You just peel the slag right off, no problem. So I'm going to switch over to 70/14 5/32 diameter, and even going to turn the machine down to 170 amps with a bigger rod. And now look what we got. I got a really hot puddle even with a bigger rod, but it's a lot clearer, a lot easier to see the puddle and distinguish it from the flux. Flux, slag, and it's flux when it's on the rod, slag when it's melting, I guess, or slag when you peel it off. I'm not sure, but you know what I'm talking about. And that was so hot, it left quite a crater that I went back later on and just kind of filled that crater in just a little bit, but ran better. Still not great, not very pretty at all. But this machine died on me about this point. Not while I was welding, but the fan just quit, wouldn't weld, wouldn't strike an arc. So I don't know what's up with that. Maybe that's why it was groaning. So I'm gonna do the remainder of the stick welding with this little TIG 175, which is an excellent stick welder. Got a really good arc. And for these rods, I'm only going to have to set it about 135 amps for this 5/32 rod, and it's running nice. A lot smoother arc. Things are going a lot nicer than they were with the Thunderbolt. Let me put my instructor hat on for just a minute here. There is an acronym called Clams, and it stands for current setting, length of arc, angle of electrode, manipulation of the electrode, and speed of travel. And if you think about all those things, you are pretty much covering every base when it comes to stick welding. I'm holding a really tight arc here with enough current. I always tell people, set the machine hot enough so that when you hold a tight arc, the rod doesn't stick. Then hold a tight arc. Best advice I could give anybody for stick welding, whether it's overhead or vertical or flat or anything like that. But that Clams thing pretty much covers all the stuff that you need to think about when you are stick welding, or any other type of welding for that matter. All the stick welding's done now. I got a little wire cut brush here. I'm going to try to get all the little remnants of slag from the weld, but also I'm going to put it in this little de-burr machine, which is basically a big rock polisher. It's a tumbler. It's got a bunch of little polishing rocks in there. It's got some water coolant that's pumped in there to keep things wet, keep the dry dust from getting all over everything. And I'm putting both parts in here, and they're going to not only de-burr it, but they're going to give it a nice even finish all the way around. We're going to put them in there for several hours. This thing has come in handy for a lot of jobs. Imagine having to de-burr 100 parts as opposed to just being able to put some parts in there and go to bed and let them tumble for a while. So they got a nice even finish on them now. I'm going to wipe them down with mineral spirits here before I give a little clear coat to them. And I kind of like the way they look. Kind of like how they turned out. They were in there for several hours. It takes a while, but you can be doing something else. And I decided just to leave the residue that was on the toes of the weld, the polishing compound that comes off the rock kind of impacted on the toes of the weld. I decided just to kind of leave it on there and lock it in with the clear coat. I kind of like the contrast, kind of like the way it looks. So after several coats of this and letting it dry, this is what we have here. Nice industrial look. And you can see on the toes of the weld the powdered stuff that got impacted there. I just sprayed a bunch of the clear coat on there, locked it in place. Now, why do I have 5 copies of metals and how to weld them? Lincoln, the James F. Lincoln Foundation is something I've been promoting for a little while now, and in appreciation for promoting them, they sent me 5 copies of this. I don't need 5 copies, so I'm going to do a giveaway pretty soon. Stay tuned for the details on that. Thanks for watching. Hit the subscribe button if you haven't yet. If you like this sort of thing, please visit the Weldmonger store by clicking the Visit the Store button. Have a good Thanksgiving. We'll see you next time.